Welcome back to our lecture. In the last section, I talked about continuous integration and automated testing processes. Another process associated with our software code pipeline is continuous delivery. And continuous delivery is this notion that whatever software code we are creating and we are pushing into our software pipeline is ultimately going to be deployable. This notion, and I mentioned it when we talked about continuous integration, that as a software developer, if I'm pushing code into the software pipeline, I have to be doing so with the mindset that my code is going to end up in production at some point. If we are following a continuous delivery practice, then our organization is ensuring that we always have software code which is deliverable. And so when our teams are writing software code, they are prioritizing keeping that software deployable. And they prioritize that even over creating new features. If we have a software delivery pipeline and our pipeline is broken, then the team should stop what it's doing, should stop working on building new features, and they should identify what's wrong with the pipeline to keep the code flowing throughout our software delivery process. Here's a diagram kind of showing how continuous delivery is associated with other practices like continuous integration and agile software development. Oftentimes you'll see companies talk about continuous integration and continuous delivery in sort of the same sentence, and they'll call it CI/CD for short. The continuous integration process is primarily concerned with the initial building and deployment of code into the software delivery pipeline. The continuous delivery process is concerned with actually releasing that software code. So it's concerned with the not only just the building of the code, but the testing of that code and the progression of that code through the software delivery pipeline. And ultimately, the goal is that your company always has code that it can release. It always has working software at the end of that pipeline. In traditional software delivery, we are trying to manage the risk of the changes that we are introducing to our software platform by changing code infrequently and only when absolutely necessary. Oftentimes, we'll schedule code changes at very inconvenient times. Maybe we'll even create assign a maintenance window on our software. We'll contact our customers, we'll send out a broadcast message and tell them that our software platform is going to be unavailable between 2 a.m. and 3 a.m. on a Saturday morning. Of course, that doesn't work very well if you are if you're supporting a global platform, because you're going to have customers awake and using your platform at all times of the day, 24 hours a day. So there's no convenient time then for your customers. And because, as a traditional software organization, because you are changing your platform infrequently, what will happen over time is that you'll accumulate changes, because your developers are always working on changes. Change is inevitable. It's always occurring. And what will happen is that when you decide to deploy changes to your software platform, you'll batch up a number of changes. So you'll have large batch sizes of changes that you'll be deploying all at once. And this leads to the traditional software deployment process, which is a big bang release, where you have a large set of changes in your platform and you're deploying them all at one time, and you're deploying potentially thousands of changes. You're doing big database migrations, and all of your customers are going to experience the same change at the same time. And once your software has been deployed, then people will quickly try to test the production platform to see if it's still working. And I call this sort of the spray and pray approach, where you're just throwing out that software, you're deploying it all at once, big bang release, and then you're praying that will actually work. And as I mentioned, oftentimes you're doing this at a really inconvenient hour. And that's a time generally when people are sort of at their worst, right? I mean, if you're an engineer typically working during the day and then you're asked to deploy a major software change in the middle of the morning, then that's not a time where you're generally awake. Your body is half asleep, and now you're being asked to work on some mission critical work at a time when your brain is half shut off. And if the deployment to the production environment doesn't go well, then you're going to have to potentially roll back the change that you just made, and hopefully that was tested by your software developers. Oftentimes it wasn't. Or you're going to have to deploy another change, another set of changes to fix the changes that you just recently deployed. So now you have to quickly do another build and another set of changes, and your traditional software company isn't used to making multiple deployments because they're only making one deployment a quarter or a couple deployments each year. And so the risk is really ratcheted up if they have to make subsequent deployments to fix the earlier ones. In a DevOps organization, in terms of our delivery practices, we are focused on making small sets of changes, but we're delivering those small sets of changes more frequently because we know that in order to maximize the throughput of work in our software organization, we need to work in small batch sizes. And that's been proven by Little's Law. The other big benefit of these frequent software deployments is that it allows us to deliver value faster to our customers and at a much lower risk because we're making fewer changes to the platform. In a traditional software organization, they might be working on features for months and months and months before delivering those features to their customers. And that's like inventory that's sitting in a warehouse. It's not providing any value whatsoever until it's actually been shipped to customers. Versus a modern software organization that's following DevOps practices, we are constantly shipping software changes to customers. We have a constant flow of changes that are producing value for a customer. A customer doesn't have to necessarily wait months for changes. They're seeing changes happen possibly every day, every week, but it's a very gradual set of changes. Oftentimes I've worked in the past for highly regulated companies, and some companies in the healthcare space. And what they tell me is that their customers don't like software updates. Their customers don't like change. And so when you talk to those CIOs and CTOs about increasing the frequency of change, they tell you that that's a non-starter. That's not going to work for their customers. And the reason why is because their customers have been burned so many times in the past, because their customers have only ever experienced big bang deployments that contain hundreds or thousands of changes. And so naturally their customers don't want to see changes. They don't want to see software releases because every software release results in a major headache for them. But if the software changes are delivered more frequently and the software changes are much smaller, then what customers will see is they'll experience a platform which evolves over time, gradually and more slowly, and they'll experience much less risk, because the sort of the scope of those changes is much smaller. Sometimes companies make the mistake of thinking that more frequent software releases means that we're actually going to be able to, sort of like deploy more software code. That's not really the case. When we talk about deploying changes more frequently, we're talking about deploying smaller sets of changes. And so, during any sort of time scale, if you think about, how many software code changes are we going to deploy over the next quarter, over the next 3 months, well, whether you're deploying changes every week or every day, or if you're just doing all of the changes all at once in a big bang deployment at the end of the quarter, you're going to be deploying the same amount of code, the same amount of features. The difference is that by deploying much smaller and more frequent code changes, the risk is far smaller, because essentially, the rate of change is slower. Instead of this large amount of change where you've introduced hundreds of new features and thousands of changes, those changes are happening very gradually. And so the risk of each individual change is much smaller, even though that change is happening more frequently. Another way to think about it is, and as I mentioned, is sort of the scope of the changes. And these small batch sizes allow us to minimize the impact, minimize the risk of the change. Oftentimes we call this the blast radius of the change in our environment. I mean, again, imagine you're deploying a big bang release that's, these database migrations, thousands of changes. You're impacting maybe every single part of the platform. The risk is really, really high that something is going to fail. Whereas if you are simply deploying a very small change, it's only impacting one particular part of the platform, then the risk is going to be much smaller. And if you roll out that change, if you deploy that change and it causes a problem, then it's likely going to be easier to fix. It's going to be much easier to identify the actual cause of the problem, versus if you were to roll out thousands of changes, you might have a very difficult time trying to figure out which exact change is causing the behavior that you are seeing in your production platform. One thing I want to note is that there are many companies that use the terms deployments and releases the same way. But in a DevOps organization, they actually have different meanings. And this impacts the way that we deploy and release software to our customers. When I talk about a deployment, what I'm talking about is the installation of software code in a particular environment. When we deploy a new version of our software code into production, we are essentially installing that software code on the production system, in the production infrastructure. When I talk about releasing software code, that's the process of making the software code available to our customers. And you might be thinking to yourself, well, if I'm installing that software code into the production environment, isn't that just making the software code now available to my customers? And in many cases, that's true. In many traditional organizations, when you deploy software, it's essentially the same as releasing it, because customers are going to see and experience those changes immediately. But one of the keys to successfully releasing software to customers is to decouple our software deployments from our software releases. And by decoupling, I mean that we separate the two. So when we have the ability to deploy our software, but then actually release our software to customers at a different time. So imagine a situation where you are upgrading your new healthcare platform that you're developing, and in order for customers to use your new healthcare platform, they have to upgrade their mobile app client at basically the same time. And so you send out a message to your customers saying, hey, we are upgrading our healthcare platform at 2:30 a.m. Central Standard Time tomorrow night or tomorrow morning. And you will need to upgrade your mobile application at the same time in order to continue using our platform. Now, think about all the major internet companies that are out there, the Googles and Facebooks and the Netflix of the world, Amazons. Imagine if they operated like this, where the deployment of their platform was tightly coupled to the release, and they would have to force their customers to upgrading their client software to continue using their platform. If that was the way that they operated, they certainly would never have been able to grow to the size they're at today. They never would have been able to successfully scale because customers just wouldn't put up with that sort of inconvenience. And if you have a healthcare platform that maybe it's supporting the health and care of patients, you would never want to put your customers in this sort of situation. And so that's why we want to be able to decouple our software deployments from our software releases. And in order to do that, essentially what we need to do is we need to be able to design our software in such a way is that we can support multiple versions of our software services running concurrently in a production environment. So in a sense, we have a platform that's designed to always stay running and a platform that will never have a maintenance window. It requires us to version our APIs and even the payloads of our APIs. And we can also leverage a pattern called feature flags or feature toggles in our software application. And feature flags will allow us to decouple our deployments from our releases. So essentially what that means is that all of our code changes that we're making are going to be versioned and they're going to be wrapped in essentially like an if-then-else block that is going to be controlled by a configuration variable. And what this will allow us to do is that when we deploy our code into production, we will have the ability to turn code on or off depending on one of these feature flags, which is essentially like controlled by something like an environment variable. This allows us to even deploy code that is sort of a work in progress into a production environment. And we oftentimes call this dark code. This is code that we are still working on that will never be exercised in the production environment because we have turned off the feature flag. What a lot of people don't realize is that if you're using a platform like, let's say, Facebook, you go to the Facebook site in your web browser and your mobile client. What you might not realize is that all of the features that Facebook is going to be releasing in the next 6 months, the code for those features has already been baked into the web client that you're using. The code is already there. It just has not been turned on. It's turned off in your environment, in your computer, in your phone. It's turned off using a feature flag, but it's there. And they can selectively turn it on when they want to. And so that's a way that allows them to progressively roll out new features and capabilities to their customers. And instead of a big bang deployment where all of their customers experience a new feature all at once, they have the ability to roll out a feature to 5% of their customer base and get some feedback and do some A/B testing, and then they can progressively roll it out to larger sets of customers as they gain confidence in the performance of the new feature.